Good morning to all of you. I am Shelly Singla from GPC Kuni Majra. Today my topic is scalar and vector quantities, their examples and their properties. So first of all we will define what are scalar and vector quantities. Scalar and vector quantities. So firstly we will define scalar quantity. A scalar quantity is that quantity, that physical quantity which is described only by its magnitude it has no direction. It has no direction. So the scalar quantities can be added, subtracted, and multiplied by simple laws of algebra. So these are those quantities which are having only magnitude and there is no direction, and these can be added, subtracted and multiplied easily by using simple laws of algebra. The examples are area, volume, speed, length, mass, time, charge, energy, work, etc. So all these quantities are having only magnitude, so these are called scalar quantities. Now next we come to the vector quantities. So those physical quantities which have both magnitude as well as direction are known as vector quantities. So the quantities which are having both the value and can be described by any direction are called vector quantities. These can be added, subtracted and multiplied by using laws of vector algebra. So there are some laws which of vector algebra which are used for the addition, subtraction and multiplication of vector quantities. The examples of vector quantities are displacement, velocity, acceleration, force, torque, momentum, etc. So all these quantities are vector quantities. Now we come to the topic of representation of a vector quantity. How to represent a vector quantity? As we know that simple scalar quantity can be described by a number which can be 1, 2, 3 and so on. It can be pi, exponential, all these are the scalar quantities. These are only numbers. But to represent a vector quantity, we take a line with a arrowhead. This is a arrowhead and this is the tail of the arrow. So the length of this arrow gives us the magnitude of vector quantity. And the direction of arrowhead gives the direction of vector. So in which direction the head is pointed, it represents the direction of the vector quantity. So suppose we take this quantity as vector quantity as p, so it can be represented as p vector, p with the arrowhead. So any vector quantity can be represented by a symbol p with an arrowhead. So if we take p vector magnitude mod, it gives the value of this vector quantity. So p vector mod is equal to simply a number which is p. This gives the magnitude of p vector. Another way of representing a vector quantity is, suppose we have AB vector, the tail is at point A and head is at point B. So this vector can be written as AB vector. So in this way we can represent a vector quantity. Now the next is the Types of vectors. There are many types of vector quantities, vectors. So first type is the negative vector. As the name suggests, a negative vector is a vector which have same magnitude as that of a given vector but opposite direction is called negative vector. Let us take a vector which is p vector. It is represented like this, and if we have to take its negative vector, then we take the length of this line same as that of vector p, but the arrowhead will be in the opposite direction. So this vector can be represented as the negative vector with minus p vector. So the next is the equal vector. Equal means, suppose we have 2 or more than 3 vectors. So 2 or more than 2 vectors are equal if they have same magnitude and direction. So equal vectors can be represented like, suppose we have 3 vectors p, q, vector p, q and vector r. If these 3 vectors are having same length and same direction, they are called as equal vectors. Now the third type of vector is the unit vector. A vector having its magnitude as unity is called unit vector. So a vector which is having the value 1 is called unit vector. It can be represented as p cap. So the symbol is p vector with the cap, which is p cap or p hat, is called unit vector. A vector divided by its magnitude gives the unit vector. So let us take a vector p vector and divide it by its value only p. So this is equal to p cap, which is the unit vector. Suppose we have three coordinate axes which are perpendicular to each other. This is x axis, this is y axis, and this is z axis. So three unit vectors are represented in this coordinate axis. The vector which is along x axis is I cap, unit vector which is along y direction is called j cap, and along z direction is called k cap. So I cap, j cap and k cap are three unit vectors perpendicular to each other. Now next is null vector or zero vector. The symbol is 0 with the vector sign. So a vector with 0 magnitude and any arbitrary direction is called zero vector. So zero vector is having its magnitude as 0 is called null vector or zero vector. Now next we come to the co-initial vectors. So two or more than two vectors are co-initial if they have same initial or starting point. So let us take some vectors. Let us take some initial point which is O, and some vectors are originating from this point O. This is A vector, B vector, C, D vector, this is E vector. All these vectors are having same initial or starting point, so these are called co-initial vectors. The next is coplanar vectors. So two or more vectors which lie in same plane are called coplanar vectors. So suppose we have the plane of a blackboard and all the vectors which are in this plane of blackboard are called coplanar vectors: A vector, B vector, C vector, D vector. All these vectors are in same plane, so these are called coplanar vectors. So now next is the collinear vectors. The vectors which are in same line and which are parallel to each other, parallel or anti-parallel to each other are collinear vectors. Suppose we have two vectors P vector and Q vector. If they are parallel to each other or anti-parallel to each other or are along the same line, are called collinear vectors. Now next we come to the properties of vectors. The first property is the addition of vectors. As we can add two scalar quantities similarly by using laws of vector algebra, we can add two vector quantities also. So first case is if two vectors are in same line. Let us take two vectors A vector and this is B vector, and these are in the same direction and we have to add these two vector quantities. So the result would be, on adding these two vectors, the third vector quantity will come into play, whose length will be same as that of A and plus the length of B. So this is vector quantity C. C vector can be written as E vector plus B vector, and the length of vector C is equal to the length of vector A plus the length of vector B. Suppose we have the length of A vector is 5 meter and B is equal to 2 meter, then the length of vector C would be equal to 7 meter. So we can add like this: if two vectors are opposite to each other, suppose we have two vectors which are opposite in direction. A vector is along this direction and we have to add another vector B which is along this direction. So when we add these two vectors, the result would be, suppose this is D vector. D vector is equal to A vector plus B vector. This is addition of A vector plus B vector. but the length of D vector would be equal to the length of vector A minus the length of vector B. As we have taken the example, A is equal to 5 meter, B is 2 meter. So, the length of vector B will be equal to 3 meter. So, this will be length of A minus length of B. This is equal to 3 meter. Now, the third case is two vectors are at an angle to each other. Let we have, this is A vector, this is B vector, these are at some angle to each other, the angle between A and B is theta. Now, there are two rules for addition of vectors. First is triangle law. Of vector addition. The second is parallelogram law of vector addition. This is valid only for the addition of two vectors. If we have more than two vectors, then we have polygon law of vector addition. This is used for the addition of more than two vectors. So, firstly we will take the triangle law of vector addition. Let us take those two vectors, A vector and this is vector B. The angle is theta between these two vectors. So, according to triangle law, this can be, this shows this is a symbol of triangle. According to triangle law, if two vectors taken in opposite order represent two sides of a triangle, then the third side taken in same order, this is same order, then the third side in opposite order represent their resultant. Vector. The resultant vector is the result of these two vectors. So, which produces the same effect as these two vectors would produce collectively. So, for triangle law, we have this is A vector, this is B vector, the angle is theta between these two. We have to add these two vectors. So, firstly we will take a vector A this is initial point of the vector. So, we put a second vector on the arrowhead of vector A, this is B vector. So, these are two vectors taken in the same order, these represents the two